When we left off, we had basically started the process of tearing down and rebuilding the entire drill press. And I said that when we come back, it'll be because we have some bearings to put in. Well, oh, bust my buttons, I think that's today. Well, okay, so I didn't get the bearings for the drill press spindle yet, but I do have the bearings for the motor. At least I hope so. These guys cost me, there's only one bearing here. I ordered two. Why is there only one bearing here? Or are they in the same, oh, they're in the same box. Okay. Here they are. So, the original bearings are these new departure, what are these? 40, I can't even read that one. ND8013s, and the new ones are basically the modern equivalent. Now the original ones are only sealed on the outside. These are sealed on the inside and the outside. Alright, so are they the same size? I think they are. Okay. Now, I believe these go in with the extended side, the extended race facing the inside. So we're going to just drop those little buggers in. Looks like the, I'm going to have to sand the motor shaft on one side because it's a little munged. But I should be able to drop this one in at least. And I'm going to take the other one. And what we're going to do is take some sandpaper. Here's some used 400 grit. Address the shaft a little bit. Now, I was incorrect. When I got this drill press, I thought that the motor was a converted bench grinder. I mean, it's an easy mistake to make, right? So I'm thinking that somebody just took their bench grinder and stuffed it in here. And that's what happened. And as it turns out, this is a good and proper motor for power tool applications. This is not a bench grinder. I was wrong. It might have been used on another tool at one point in its life, but ultimately that's not the case. So, as I understand it, these little spring-loaded dealies, I saw the blow-up diagram of this motor, and I do believe that they go in like this first. Fit right in there. Put one side on first, then we'll do the other. Now, after the spring dealie, it gets a felt pad. Now that doesn't seem. Let me pull up the blow-up diagram and see. Okay, so it looks like I'm doing it right. The felt seal actually goes after this plate, so there should be a gasket on this plate, and that goes towards the motor. The felt seal goes on the outside. And the purpose of the felt seal is to keep the dust and debris out of here. Remember, the original bearings are open on the outside, so that was what the felt seal is for. And we're just going to go like that. Oh, I got this one backwards. Take one of our newly cleaned up. I'm going to put the nicest one on the top side, which is going to be not this side. This is the bottom. We're going to get some of the nice polished screws. We're going to put those back in. So yeah, this motor is designed to be either an original equipment or replacement motor for really any tool requiring a motor of this size. So it's not out of place on the drill press. As a matter of fact, it's probably not a very uncommon motor to find on a vintage drill press, regardless of brand, because these could be purchased from the Sears catalog by anyone. No special anything required. You just go to the Sears catalog and you're like, I need a 1/3 horsepower rated at 17 whatever 100 RPM, and oh look. Now this motor was made by Packard, so it could have been purchased under a variety of names, including perhaps even Packard. And the other side done. The other side, I got a little washer here. I didn't have that washer on the other one. Oh, that's okay. Wow, this thing is already looking good. It seems like it might spin a little bit nicer, if you can imagine. That's going to be nice. If you watch the previous video, towards the beginning, you can hear what this motor sounded like. In fact, I have a couple of videos of this drill press from prior to all of this. And you can hear it run when I first got it, and it was, boy, was it rough. She was a rough running motor, I tell you. I'll tell you what. Yeah, she ran real rough. In fact, that's kind of an understatement, as a matter of fact. She was a very rough motor. I didn't think I was going to be able to save this one, honestly. It didn't look promising at first. So, now that we got all new bearings installed, the new departure bearings can now be the newly departed bearings because they junk. All right, give it a good test spin. Yeah, I think she's good. She's gonna be good for a long time. Let's. The original bearings lasted 80 years. These should last quite a while. Let's light it up. Ready, set. Well, it's better. Not bad, huh? What did it sound like before? It's pretty bad. Stand the shaft up a little bit. Perfect. Absolutely perfect. Well, I think the rotor's a little out of balance, to be honest. Now before it was kind of a clack, 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 you know, kind of sound. She's spinning free. Now we can at least get the top of the pulley back on. We're going to mount it back onto the drill press. I'm going to get that part done and over with. And we can at least move forward with some of the reassembly tasks. And I think we'll be off and running. Yeah, what a good running motor. What a good running motor. And the thing is, motors like this, in this condition, see, there's a little bit of play. Now, it's not the bearing it has the play in it, it's actually the bearing mount. Feel that? Hear that? It's got some play in it. And it's not because the bearings are bad, because they're brand new. Kind of wonder how she'll sound under a load, though. Now, we can shim the bearings. I could probably throw some like plastic gauge or something in there and shim it. But I don't think I'm going to have to do that, really. Side fumble in the shaft. Well, the pulley's not true, and that's not much I can do about that, but you see that? That will only be a problem if it's a problem. If it is a problem, I will fix it. But it's just the fitment of the bearings isn't as tight as I'd like it to be. That could be by design, or it could be due to, I don't know, maybe perhaps at one point the bearings had seized up and ruined the race. I mean, who knows? We're going to have to keep our eye on that. Once I get the spindle bearings all replaced, we'll know more. And again, it's not that big a deal. Just take the bearing out and shim it a little bit. You know, that wouldn't be the hardest thing in the world to do. All right, so I contacted Hammer Scale Technologies. They're the ones who still make replacement parts for these beautiful old drill presses, and I've ordered a new spindle bearing. I have ordered the spindle rebuild, which will replace both upper and lower bearings in the spindle and true the chuck taper, and not spindle bearing, the pulley bearing. I also ordered a stainless steel pull down lever with 2 red knobs, one on each end. I've also gone on eBay and I ordered the correct stop rod. This is really just a threaded bolt. This is not the correct part. This does not belong here. Or maybe it does. I don't think it does. But I've ordered the correct part nonetheless. That actually is not correct for this drill press, I'm fairly certain. So, we've got all that on order. We're going to make this drill press like new again at the end of the day. And I can't wait to see how it comes out. The paint is looking pretty good. I'm going to coat the shaft with grease so that it doesn't rust. But first, we need to strip the paint off the base, and I'm going to do that starting now. So I bought a can of aircraft stripper. This is nasty stuff. You don't want to be messing with this. I don't want to be messing with this. Nobody should be messing with this stuff. It's nasty. It's awful to work with, but it's all we got, and it works. And you brush it on the paint, you let it sit, and then you wire brush off the crap that comes off, which is going to be, in this case, 2 layers of paint and maybe a little rust. So let's do that. Okay, this is after about 3 applications and hand stripping it with a combination of a wire brush and oh my god, these fumes are getting to me. Those look like cat paw prints to me. What do you think? Yeah. Okay, so here's the issue. You can see there's a little bit too much play on the shaft. So what's happening is the shaft is knocking against the inner race, and it's not the way the bearing fits in the motor casing. It's really just how the shaft is free to wobble. So we had a problem where there was a lot of clearance between the shaft and the bearing's inner race, as well as the outer race and the motor housing itself. So what we've done is I brainstormed, I talked to my father. My father's a machinist. He's been a machinist for 30 years. And he gave me the idea, I'll give him credit for this one, of using a feeler gauge set. You buy these in the auto parts store and they come in various thicknesses. But some of the thinnest ones are like paper thin. And I was able to take one of these feeler gauge blades, wrap it around the shaft, and tamp it in between the shaft and the bearing's inner race. And I mean, it ain't perfect, but here's the thing. The way this motor is designed, the bearings are supposed to float, which allows the shaft to kind of move up and down a little bit as needed. I've never seen a motor designed this way, but then again, I don't work on a lot of motors like this. So I had to, it was a delicate balance between making it able to float and keeping everything in line. Let's fire it up. It's still not tight. Now that sounds a lot better, if I do say so myself. You're hearing all the other shit vibrating. The motor is not well balanced, that's for sure. Alright, today's a big day. Oh, there it is. So, I've been waiting for this part for quite some time. About a week, 2 weeks, about 2 weeks. This is the rebuilt spindle assembly for the 1936 Delta drill press. Now this is the part that I sent out to have it rebuilt with new bearings and some additional work done. And the company that I sent it to is called Hammer Scale Technologies, run by a gentleman named Gary. This looks like his contact info. If you guys need this kind of work done. He specializes in Delta drill press parts. And what makes his service so unique is that what he does is he actually custom machines or has manufactured replacement bearings that are no longer in production. And looks like he took my chuck off. So we've got the kind of hoping that he wasn't going to do that because I don't know how to put it back on. Oh man. Or I don't have the ability to put it back on. So this is the replacement pull-down lever with the red knobs. And here's my spindle. And yeah, there's no chuck on this guy. So this is how it comes from that place. Alright. So this is it. All rebuilt with new bearings and no chuck. So how the hell am I supposed to put this guy back together? I honestly don't have a friggin' clue. So I'm gonna have to ask him because I don't know. I don't know if it's pressed on or what. And these parts are absolutely freezing. I literally don't know how to put it on. Okay. Here we go. Let's see. Got about 18 thousandths of an inch run out on chuck with precision end mill held in jaws. I would rate chuck as fair condition. May or may not want to replace, so I'll leave. Ah, damn it. Oh well. Okay, so I'm glad that I kind of read up on this because it's actually not that difficult. You need a clean, lint-free cloth and some solvent like an alcohol or preferably acetone, but I don't have any acetone. And you want to clean the inside of the taper and the outside of the male taper thoroughly of grease, dust, solvents, oils, whatever. Not solvents, but you know what I'm saying. Then what you do is you just set them together. Make sure you, yes. So that's a nice, good, clean, well-machined taper. Make sure the jaws are fully retracted. And then we're going to take a block of wood, pieces of wood, I don't have any little ones, and you're going to tap one good whack like that. And that should be fine. So yeah, he was nice enough to include that little rubber bumper, which I never had on this one. So when it returns, it has a nice soft place to land. Nice touch. Nice touch. Okay. This goes in there. I'll knock the and I'll put that in there. There we go. Make it easier to manipulate while I'm putting stuff into position. Nice, brand new bolt. Well worth it. Now there's a lot of slop here, so I'm gonna do. See, when you spin this, it spins the bearing too. That should not be. Unless tightening this down, yeah, it doesn't tighten the bearing. So we've got to, we don't want this pulley spinning in the bearing like that. So I'm going to take some of this feeler gauge material. I'm not so sure this is the right way to do it, but it's certainly a way to do it. So I'm going to take this feeler gauge material. We're going to see. Yeah, it's really a very small amount. I'm sure there's a better way than what I'm doing. Given my resources, I'm going to do what I'm going to do. So you looky here, what I did is I took a, I forget what the size was, but I stuffed it in 3 positions all around the perimeter. And look at that. It's nice and firmly installed. Let's try that again. So we'll take these, we're going to put them right where the screw holes are to keep them balanced so that it stays centered. Thank God feeler gauges can be had for a song and a dance, because it's a cheap way to fix it. See, now when I rotate this, it spins only the inner race, not the whole bearing. We'll attach this guy where it goes. There we go. applying the spline. Ooh, look at that. Oh, there we go. I just watched I read an entire article from my favorite jalopnik columnist, David Tracy. And what he did is he was working on a friend's late model Mini, and he was replacing a motor mount. And those cars are all kinds of fun to work on by themselves. But when you have a problem like a cross-threaded screw or bolt, in this case it was an engine mount bolt on the chassis. Oh yeah, a wicked good time. It took him like 10 hours to correct that one mistake, which is really sad. So yeah, that's just a letter you don't want to write home to Mom about, especially on a big expensive German car like a Mini Cooper. But anyway, so we're gonna just get some tension on that guy. Okay, pretty much most of the work here is done. When you guys weren't looking, I put some grease into this assembly here, but we got to get some tension on this guy. So we're going to take the spring and put it back on. Okay, I figured out what was happening. There was a little tiny piece of broken spring from from when it had broken a while ago. That's all it was. And it was preventing it from going in all the way. That's all. Mystery solved. Now we can unthread this a little bit. Turn it a few times. We want there to be enough pulling force for this guy to spring back on its own when there's a tool in the chuck. Maybe even a little more than that. Okay, first thing we're going to do is we're going to just do a quick test run with nothing loaded. Very nice. Very smooth. As smooth as it's going to get, given the circumstances. Alright, motor's back on. Let's see how she runs on super speed. Because of all the play in this pulley up here. Yeah. It's as good as it's going to get, I guess. Hey Alexa, turn off. Oops, wrong one. Hey Alexa, turn off. Wrong one. Oh, I know which one she's plugged into. It's in the one with the. It's the one the refrigerator's on. Hey Alexa, turn off. Yeah, I got it. So I've come to the conclusion that I can't leave this like that. I've got to do something. So what I'm going to do is we're going to pull it apart. I'm going to pull the pulley off. And we're going to secure it using an alternative method. Alrighty, folks. What are we gonna do for this little thing? Problem. Well, I have a plan. I have a plan. It's not a very good one, but it's a plan. And what I'm going to do is we're going to remove all the grease from the bearing itself. We're going to just wipe it clean with some rubbing alcohol here. Now clearly the bearing itself isn't the problem. The problem is the pulley. For whatever reason, the bearing bearing cavity, or whatever you want to freaking call it, it's just not, it's too big by like a couple thousandths of an inch. We can't shrink it, and I tried shimming the bearing in with well, literal shims, and it didn't quite do the job. So what we're gonna do, we're gonna put it back in, but we're gonna use a little epoxy. Yeah, I know how that sounds. I know, but we're gonna, the thing is, if we do nothing, what's gonna happen is over time it's just going to wear away at the aluminum pulley itself. It's going to wear it out even more, and it's going to be an even bigger problem. That's what happens in these situations. So we need to do something to stop it from getting worse. So I'm going to use some self-mixing epoxy and then we're going to center it with the shims. What do you think? Okay, there we go. So this is DevCon self-mixing epoxy. Alright, so what I have here is a DevCon self-mixing epoxy. Well, it's self-mixing in that it includes a mixing tip that will when the epoxy flows through this tip, it mixes. This stuff is pretty common in the industry and works really well. But it requires a nice clean surface. I've actually bought a few different brands of this stuff. One of them being Loctite makes a great epoxy using the same mixing technology. And I think I tried one from another company as well. I think it was Gorilla. No, it wasn't Gorilla. But the downfall with these is they only come with 1 or 2 sticks. And when that stick is used once, it can never be used again. So, anyway, I'm going to put a nice bead of this stuff on the inside of that, right there. Okay. And we're going to squeeze our bearing into position, and we're going to force her into submission. I'm going to put my shims back in just to make sure it stays centered, because that would be a travesty if it was, you know, permanently off center, and that would be really, really bad. Now, what happens if we have to replace this bearing again? Then what? Well, I don't think that's going to happen. I don't think this bearing is going to wear out in my lifetime. I have to say, I just don't think it's going to be my problem. It'll be somebody's problem, but it won't be my problem. I assure you it won't be my problem. At that point, now you can get this stuff. What's going to happen is, if it does actually fail again, what's going to end up happening is the whole pulley will have to be stuffed in a furnace and you're gonna cook the shit out. That's what's gonna happen. It's gonna have to be heated out with a torch. And again, not my problem. I'm not too concerned. It'll be fine. The original bearing lasted 60 years using 1930s, 80 years. The original bearing lasted 80 years in a factory setting, or probably about 40 of those years were in a factory. And you know something? It was still usable. At the end of the day, it still worked. This replacement bearing is made with modern technologies. It's a very good quality bearing from McMaster Car, and not that they don't sell junk, but you know, it's a good bearing, and I think it'll be just dandy. That's my opinion. It is what it is. So we're going to let that cure for a couple hours, and then we're going to pop it in and see how she goes. Alright, at this point, these two shall be wed. So let's put her back in. I chose this particular camera angle to increase the illusion of the height of this particular chain. Yeah, I thought it was cool. Now we got to line up. Oh yeah, little tidbit. So this is an earlier model drill press. So the spline is part of the pulley rather than a removable, replaceable piece. Later model drills had a much better design. A much better design. Alright, let me flick the power switch on. Let's see what she does this time. Make sure nothing gets caught up in the spindle there. Well, it sounds a lot better. I think that sounds a lot better. What do you guys think? Let's put it on low speed. Sounds pretty good. I think it sounds pretty good. What do you guys think? You know, I think that's alright. Let's put the guard back on. So I'm going to start it up, and you're going to see there's a little bit of a run out. And we're going to see how that actually affects the piece you're working on. Here we go. So if I just go like this, probably a stupid idea. Here we go. Now, you can see there's a little bit of movement, but not much. Look at that. There's a little bit of movement, but that's better than it was. By quite a bit. By quite a bit. Before, it was like this, I think. Oh, it was pretty bad. But this isn't so bad. Going a little too fast there. I mean, I can use that. You know, that is well within reason. I think we have a winner, guys. I think we do. I'm gonna leave things as they are with this machine for now. I'm not gonna put any more money into it. I've already put, Christ, $300 I think into this machine. And you know, again, that's about twice what a New Harbor freight drill press would cost. But even in this condition, it'll outlast anything from Harbor Freight. So, pretty sure about that one. On that note, we're going to call it a day, and I'm going to just move on with my life, and I'm going to probably start doing some woodworking with these machines that I've graciously repaired. We fixed the motor. Again, we put in the newly rebuilt spindle. And I think we're ready to start doing some work. I look forward to that. Thank you all for watching. Thank you for your support. Have a great day. What do you think about my new red balls? Huh? You like them? I like it. I think it looks nice. I think it gives it a little bit of class, you know. Makes it look more classy. Like that. You can reposition this to have the pull down in any position you want it. I put it this way because I felt it was, because I could just reach back and grab the, you know, I just think it works better that way. But you can position it any way you want. The only caveat is you have to unleash the coil of terror to make that happen. So I don't really want to do that right now. But I actually thought about positioning it a little bit differently, but I'm not gonna. I'm just gonna leave it alone. And side note, this piece here that I bought from Hammer Scale, the balls are threaded on rather than attached with set screws like the original was. And this is a stainless steel bar. It will never rust. It will never ever rust. So, well worth it. I mean, it cost a bit of change, but I think it was worth it in the end.